We're looking at single logarithm equations today. We're going to be solving them. We know what a log is, and we know how to convert between log and exponential form. If you feel the need to add that conversion off to the side or up at the top as reference, that is not a bad idea. Or you can just get out one of the previous day's notes that has it on it. Okay, but I'll jot it down here on the left to start with. There we go, my pen will work. So if we have a log base b of a equals x, that's log form, and we can change it from log to exponential form as needed by taking the base, raising it to that power of what the log was set equal to, equals the argument. Okay. I don't know if I've said it in the previous notes or not, but that what you are taking the log of is called the argument. Okay, so that A is the argument, B is the base. Okay, so we can convert back and forth between these two forms. Okay, that's what we're going to be using over here to help us solve for X. So we've got the steps listed out. We're first going to rewrite the log as an exponent. Now, today, that's step one. You'll notice as we get some more complex equations going throughout the week, there's going to be sometimes some things you have to do before you can rewrite it as an exponent. Because to rewrite it as an exponent, it has to be in this form where it's a single log expression set equal to something. Okay, you've got to isolate that log before you can rewrite it. Okay, but today these are already, the log expression is already isolated. So what is our b value here in number one? Where the base of the log here is going to become the base of the exponential. So what is our base in number one if nothing's written there? This is one of this. There was two special types of logs we talked about. If no base is written, you have log with no base, it's your common log. And what is that understood base? 10. So my base here is 10. Okay, if you need to write that in, 10. Okay, and then 10 will be the base of my exponential. Dennis, the outline's back here. Can you grab one? Then the log is set equal to 2. Okay, so 2 is going to become my exponent. And then the argument of the log is this expression, 5x minus 11. That's what the exponential will be set equal to. So is everybody good with step one? We've been practicing for a week now on this. We're good? Converting from log to exponential. Okay, so now we actually want to solve for x. So now it's a basic algebra problem, isolate the x. So I'm going to first simplify the 10 squared is 100. And then what needs to move first? Trying to solve for x. What do I move first? The 11 by addition. You move things by opposite operation. Okay, what you do to one side, you do to the other. Okay, and then you have a coefficient, so we're going to divide that out. And what you do to one side, you do to the other. So this does not come out as an integer. This comes out to 22.2. Okay, if you left it as 111 over 5, take that as well. So far, so good? Now, it says check your answer. We have not done graphs of logs yet. We're actually going to do graphs of logs at the end. of the unit. Most of our functions, we've started with the graphs and then moved to solving, but I think it might be helpful for you just to see the general shape of what a log looks like. I know I've talked about how it's the inverse of the exponential, but if I have log of x, I just want you to see, remember an exponential, let's do, I did a common log, so I did a base 10. So let me show you a base 10 exponential in comparison. So remember before spring break, we tested on exponentials and they had this horizontal asymptote here. Okay, do y'all remember that? And then they increased like that. Now then we transformed them, but I just want you to have a visual. The log is the inverse of that. Remember inverses flip across the line y equals x. There's that line y equals x. Okay, and this is a reflection across that line. Okay, so I just want you to see, instead of a horizontal asymptote like in exponentials, there's this vertical asymptote along the y-axis. So the domain of this, what I really wanted you to see, is that the domain does not go left. Okay, it doesn't go to 0. Does everybody see that? There's an asymptote, x equals 0. Yes? Okay, so I want you to understand, because of that domain, if I tried to take the log of 0, I get undefined. If I try to take the log of a negative number, I get undefined, because the domain is everything greater than 0. Okay, the reason I point that out to you is because when you go to check your answers, if you go and plug your answer in and you go type this in the calculator to see if it works, then if you get a negative number or a 0 in here for the argument, okay, that means that that is not the solution. Okay, and if that's the only solution that works to calculate this out, then it's undefined. Okay, because the argument of the log, this that's outlined in the pink, can't be 0 or negative. Okay, but as long as I plug this in and it works, okay, then that's great. Well, it'll check out. Okay, so when I go to check this, I will check, it was a common log, so I don't even have to write the base 10, it's understood, of 5, and then it was times 22.2, so it's 5x. Somebody tell me what was after that. 5x what? Minus 11. Okay, so the log of 5 times 22.2 minus 11. And you can see that came out to a 2. Is that what it was supposed to equal? Is that what the equation says? Yeah, so that checks out. So you can take your answer, your solution that you get, plug it in, and make sure the left side equals the right side. Good? All right, I'm going to start moving a little bit quicker now. All right, so here we've got, well, I know where my pen went. Oh, here it is. What is the base in this one? Okay, so we're going to have a base 3. Okay, what's going to be the exponent? This 3, good, also 3. And then this is going to be set equal to, very good, that's the argument. So now we solve. Okay, so I'm going to simplify the 3 cubed. 3 times 3 times 3 is 27. Okay, and then I'm doing basic algebra to solve for n. Okay, so n comes out to 7.25. Okay, I'm going to save us some time and let you know it does check out. Okay, But you could plug that back in and make sure that the equation comes out true. All right, now this one, 3 and 4, are not ready to change to exponential form yet. Why? What's in front of those log expressions? A coefficient. So we learned a rule, I think it was last Thursday, the power rule, and I reviewed it with you yesterday also. The power rule says that if you have a coefficient in front of your log, you can rewrite it where that coefficient comes up as an exponent, right? Don't remember that? You're taking that coefficient and making it an exponent on the argument. Okay, so that's what I'm going, actually, you know what? That's not what I'm going to do here. That would make this one more complicated since there's a variable here. I take that back. Technically, I could solve it that way, but it would get pretty complex because I'd end up with w to the negative 6, and that would be more complicated to solve for. So rather than using power rule on this one, I'm just going to divide over that coefficient. So my bad. We reviewed power rule, but we're not going to use it here. I don't know what is going on with my pen here. Well, pretend I'm getting rid of that. Pretend that's erased. So I'm just going to divide over the negative 6 that's being multiplied in front of the log to get rid of it. So now I've got log base 4, 5w equals negative 2. So then I rewrite in exponential. My base is 4. My exponent is negative 2. And this equals, my argument is 5w. Okay, now I do either need to use Desmos or I need to remember my negative exponent rules. Remember, a negative exponent tells me I can move this term in the fraction. So instead of 4, it's going to be 1 over 4 squared. Y'all recall that? Okay, but you don't even have to do it by hand. Y'all get Desmos, so you can use Desmos to calculate that for you. How am I going to get rid of that 5, though? I'm going to divide, right? I'm going to divide the 5 over. And then I'll just do that all at once in the calculator. So 5 to the negative 2 divided by, or excuse me, 4 to the negative 2. Divided by 5. So 0.0125, or if you write it as a fraction, 1/80th. Okay, so if you were doing it by hand, you probably would have gotten it as a fraction, but the decimal answer is totally acceptable as well. So W is 0.0125. And you could plug that back into the original and check it out. Make sure that that worked. Okay, so far so good? All right, so let's do the same thing over here. There is again an expression in the argument. So it's going to be easiest, instead of doing power rule, okay, we will just divide that coefficient over to the other side. So I'm going to divide both sides by 7, which will give me, bless you, log base 5 of y plus 27 equals 2. So then I rewrite as exponential, where my base is 5. And is going to drive me nuts. My exponent is 2. And the argument is y plus 27. So we know 5 squared is 25. We subtract the 27. And we get -2. Now, I don't want you to think, based on what I said earlier, I said the argument cannot be negative. That does not mean your variable cannot come out as a negative, your solution. Because if the argument is an expression, if I plug in this negative number, what's -2 plus 27? Positive 25, right? So the argument is still positive. So your answer, your solution when solving for the variable can be negative. It's the argument, this what you're taking the log of cannot be negative. Okay, but it's okay to get a negative answer. Okay, as long as when you plug it in, this is a positive value. Okay, and then it all checks out that the left side equals the right side. All right, last two on the back. Here they get a little more complicated now. We've got not a coefficient in front, but a constant outside the log function. Okay, so that -4 is being added to the log expression. How am I going to move it? How do I get rid of that -4 that's being added to the log on the left side of the equation? I add it. Yeah, it's a -4. So I'm going to add 4 to both sides. So then I will have log base 3 of a plus 1 equals 1. Okay, so now I've isolated my log expression and I'm ready to rewrite as an exponential. What's the base? Base 3. What's the exponent? The 1. Okay, and the argument is a plus 1. 3 to the first power is just 3. So then I subtract the 1 and get 2. If I were to plug that back in up here, 2 plus 1 is 3. Remember what we talked about when the base of the log matches what you're taking the log of? What is that? We just talked about it yesterday. When the base of the log matches the argument, what happens? It's just 1, isn't it? So then I have -4 plus 1. That is indeed -3. Checks out. All right, then last but not least, how would I move that 8? Okay, I'm going to subtract that 8 to the other side. So that will leave me with log base 5 of -4x equals 2. So then I will set up my exponential. The base is 5, the exponent is 2, and the argument is -4x. 25 equals -4x, and I'll divide the -4 over. So this one comes out to -6.25. And again, Your solution can be negative. That's totally fine, as long as when you plug it back into the argument, it becomes a positive argument. And won't a negative 4 times a negative anything come out positive? So that argument's going to be positive, and I'll let you know it does check out. Okay, so this is solving when you have a single log expression. What I would suggest you do, what I'm going to do on the front, is above this where it says write as an exponent, I'm going to change the numbering on these steps. I'm going to make that 2, this 3, and this 4. I'm going to put step 1 up here is isolate the log. Okay, if there is a coefficient in front of it or a constant being added or subtracted, you've got to isolate the log first. Okay, so get the log alone, then you can write it as an exponent. Okay, so isolate the log if needed. Okay, now you won't always have to do that, like 1 and 2, that part was already done. Now, these same steps will apply if it's a natural log. Okay, we introduced natural logs yesterday, and we said all the properties of logs apply to natural logs just the same. Okay, the steps for solving log equations, okay, it worked the same with a common log. It's going to work the same with a natural log. Okay, the steps don't change. The only thing that's different on those is the base. You'll feel all right about that? All right, so I'm going to activate your practice for this. Okay, don't forget, if you have anything else still showing in Delta Math besides today's, you're welcome to work on getting those finished first. There's a couple from last week that are due by 11:59 tonight. So if you need to finish those first or yesterday's, you can do that. If you're all caught up, you'll be starting today's practice.